Well, hello and welcome YouTube to Mr. Robinson's Q&A Power Hour for Integrated Math 1 material. Now, we have been working on systems of equations, word problems, and graphing systems of inequalities. And actually, over the past couple weeks, we've actually just been mostly focusing, I think, on graphing the inequalities with two variables, by the way, with an x and a y involved. No word problems on that matter, though I really do wish we did those on top of it. I think students would make a lot more sense of the stuff that we do with the inequalities. Anyway, so the point I mentioned, the reason why I'm mentioning all that is because this whole concept of Q&A power hours are every 2 weeks. I record a video where I answer my students' questions that they ask. And they should be asking questions regarding math content over the past couple weeks. And over the past couple weeks, we've been focusing on graphing systems of linear inequalities with two variables. So, or just graphing inequalities in general, not so much the number line stuff, but more so the ones, of course, where you are doing some dotted or solid line and shading above or below the line or something like that. I think we might have done some word problem things, so I wouldn't be surprised if I get some questions there. Now, I think I did have a few questions here. I haven't looked at them yet, but I pasted them in. I think there were 24 total. So I am going to go ahead and get started here. And if you're trying to find any one specific question, please look at the description section down below and find the timestamp related to that specific question so you can get your answer found. Every so often, students ask some repeat questions of sorts, like not the one student asks the same question, but multiple students will ask the same question. So if I ever run into those, I'll try and find, I always try and do this, I'll try and find a timestamp where I answer it a little more so if I felt like it was a perfect thing and it's covered exactly what they asked. So I'll find the timestamp that relates to it and say, find that time, go to your question, look at the timestamp that I also gave you so you can see the answer to that question. All right, guys, I'm going to go ahead and get started right now here. Let's see. And in Integrated Math 1, the first question that is asked is, how do you where you are supposed, hang on, probably how do you know? How do you know where you are supposed to shade? Yeah, how do you know where you are supposed to shade, and what do you mean by top and bottom? All right, so right off the bat, guys, this is like a graphing inequalities kind of question here. So to put this into perspective, what they're referring to is when we graph a system of linear inequalities or just a linear inequality itself, some sort of thing where we have a y and an x in it, whether it's in standard form or slope-intercept form to start with. What you can do is you draw what's called a boundary line. Basically draw the line as if it's in like a y equals mx plus b. Here, I'm going to write one. Let's say it says something like y is greater than or equal to negative 2x plus 4. Let's say you had something like this. What you start by doing is you start by drawing what's called a boundary line, which is basically the line that's equivalent to y equals negative 2x plus 4. And then in an inequality, there's this concept of shading. If I had the graph, super quick, if I had the graph that looked like that there, boom, we decide whether we shade above the line or whether we shade below the line. And the shading above or below is based on, in this form at least, whether your point, whether y is greater than or whether it's less than in these cases. If y is a greater than, I'm sure I'm going to type this in a second. When y is greater than, we shade above the line. When y is less than, we shade below the line. Because this one's greater than, we'll do a shading above the line. And I know you didn't get deep into this part, so I'm just going to keep this part really short here, as far as, because your question doesn't necessarily really say this. The shading represents all the points that make this inequality true. If I plug in a certain point, like probably 0, 8, 8 for y, 0 for x, I'm going to make a true statement. It'll say 8 is greater than or equal to, I guess, 4. So the shading just represents all the different points that make this thing true. And by the way, the boundary line is a solid, although you didn't ask, it's a solid line because it's a greater than or equal to, whereas supposed to be a dashed line. So you say, how do you know where you're supposed to shade? The thing that I've been telling you guys kind of as the best shortcut is if you're in slope-intercept form, greater than, whether it's greater than or greater than or equal to, you shade above the line. Above the line. So you said on top. I hope I mostly say above. If I say on top, well, on top of the line is fine. You shade above the line. And if it's less than versus less than or equal to, you would shade below the line. Now, if you say, what do you mean by top and bottom? Like, I can't tell which one is on top and which one's on bottom. I want you to think about points that are directly above any part of the line. Here are points on top of the line. Look where the arrow is being drawn when I draw straight up. These are points on top of the line right here. Points below the line are the ones down right here. These are points below the line, above and below. Straight up or straight down, just do the shading. Now, as you probably saw with my shading, I have it, you might say, this isn't on top of the line. Well, it is, because these lines go forever, guys. So if I extend the line, see how that is on top right there? So just make sure that you know the line does go forever on top. Just kind of look at the angle. The way that I've kind of said with my students is if you have a kiddo going down a slide, how would you make him go on top of the slide? Well, make sure he's on the side that, when he sets his bum down right there, he can go down the slide there. If he's below the line, kind of falls. So pretend like the line is a slide. How do you shade above and below? So I hope I answered it pretty well. I mean, I used one example just with that thing, but what I was making mention to when I was stating that, of course, is that the shading represents the actual set of points that make a true statement in your inequality, that you shade above when in slope-intercept form if it's greater than, and you shade below if it's less than. There's a way to test points as well, but I'm just going to go to the one that we've been talking about to start, unless someone else asks. Okay, the second question here is, how can you determine if you should shade... Okay, I expect a few of these questions, I guess, because like I said, what else can we talk about with inequalities? How can you determine if you should shade above or below the graphed line? So, okay, let me actually now, just to kind of feed in a little more into what to put here, let me type this in as kind of canonical, like in a canonical sense here, just what it is, all right? If you want to hear more about it from the first question, you can go back and check that out, but otherwise, take a look at this right here. If you're in slope-intercept form, and we're talking about y equals mx plus b, or in this case, y is greater than or equal to mx plus b, or y is less than or equal to mx plus b. But if you're in slope-intercept form, looking at greater than or equal to, hang on, I got to insert the symbol. There's no one way to do this quickly. Greater than or equal to means to shade above the line. That's the side we'll shade on, above the line. Or less than versus less than or equal to is shade below the line. Means shade below. Now, let's see, what did I say on the last one? Oh, the reason why you have to be in slope-intercept form to do this, comparing y to some mx plus b, and I'm not putting equals there because the whole point is we can put one of those things. So let me just maybe put a box or something. The reason why you need to be in that form to make this distinction is you are comparing some y that you choose to the y that you get by plugging in x on your line. So you are comparing the y values above the line or below the line. If the y values above the line make a true statement, then every point above the line will also be true. That's just how it works. That's how the boundary line compares to y's. So we would shade above it. And then if the y values below the line instead work, if one of them that you try works, then all the ones below the line should also work. That's why we shade below. So if you're in slope-intercept form, there's that. If you're in standard form, what we can do, if you're in any other form, but if you're in standard form, what you can do is test some point that's not on your line, and if it makes a true statement, you can shade on that side. I'm not going to write that for now, but I'll leave this one up, and then if I obviously need to add more, then I will. Okay, so hopefully just that little shortcut of notes kind of helps you there. The next question here asks, how do we know when to make the line dashed or straight when we are graphing? Now, again, this has to do with inequalities, guys. The same stuff that I was talking about before, and I guess I need to add on to this. I'll add on to this page right here to answer that. So let me move this to the side as if this was our... Whoa, hold on a second. Let me group you all together. There we go. There we go. Okay, so in talking about shading dotted line versus solid line here, what they're asking is when we graph that boundary line, normally when you guys see a line drawn, it's just a straight, just drawn line. But sometimes we dash that line up. Sometimes I say dash line, dotted line, broken line. I use them interchangeably. You'll hear me do it too here. And I don't know how to just use one instead of all of them. But right now here, what we're going to do is make that distinguishment on what's the dotted line versus what's the solid line. So if you are, I can just copy and paste these. If you're greater than or equal to, or if you are less than or equal to, you are going to have a solid line. Basically the concept that we generally see. Whereas if we have just greater than or just less than, we're going to have a dashed or broken or dotted line. I need to use all three here because I say all three. So there's the concept, or there are the notes to that. The reason why we do it is to let someone who's looking at the graph, even if it's you, let someone who's looking at the graph know whether a point on the line also works as a solution to your inequality or not. So let's say, for example, here, I need to do another page here. Let's say, for example, I don't have to do a full graph. Let me just rough it out. Okay, let's say, for example, I have something like this right here, and let's use the same one as before. Y is less than, what did I say? Greater than or equal to negative 2x plus 4. If this is my boundary line, negative 2x plus 4, I'm drawing it solid because it says greater than or equal to. Here's the point that's being made. If I plot a point that's on this line, let's see which point would work here. Let's say this is the point 4 comma, what would work? I can't do math in my head anymore. 4 comma negative 4. There's the point 4 comma negative 4. If I substitute it into here, this will end up saying negative 4 is greater than or equal to negative 2 times 4 plus 4, a whole lot of 4s. Negative 4 is greater than or equal to negative 8 plus 4, and it says negative 4 is greater than or equal to negative 4. What you get is a statement where the left and right side are equal. And when it says greater than or equal to, the or equal to allows points on the line to still satisfy this. This checks out when it says negative 4 is greater than or equal to negative 4. Negative 4 may not be greater than negative 4, but it sure is equal to it. So a point on a solid line kind of tells you that and represents that whole idea that it works. It's allowed as a solution. Any point on the line is a solution. Any point above the line is a solution. I'm not going to plug those in now because you're talking about solid versus dash, so we leave it. Now, if it was just greater than and not greater than or equal to, what we'll do is put a dashed line on here. And that doesn't literally mean that the line's broken up. It's just a visual representation of telling the viewer or yourself that points on the line will no longer work. Here's what happens when you try 4, negative 4. Then it ends up making a statement that says negative 4 is greater than negative 4. And that's clearly not true here. So what it distinguishes is the left and right are still the same, and that's not allowed anymore. So this point is no longer a solution to your inequality. Now it becomes a non-solution. Points above the line will still work, but points on the line no longer do not. So the dotted line is the equivalent, guys. If we're using a number line, if we're doing the number line graph, let's say we had x is greater than or equal to negative 4. On a number line here, in this case, what you have is, if this is 0 and this is negative 4, what we do is we place a boundary point on your x value that you're comparing your x values to. We'll close the circle because negative 4 counts. It works. Negative 4 is greater than or equal to negative 4 works. And we shade to the right because it's greater than. So these are all the x values that are either greater than negative 4 or equal to negative 4. However, if it just said x is greater than negative 4, what we do here is an open circle, which is just a visual way of us telling the audience or yourself that negative 4 doesn't count, but anything else greater than negative 4 does count for your solution because, of course, negative 4 is not greater than negative 4. So the dotted line is the equivalent of the open circle, and the solid line is the equivalent of the closed circle. The solid line is the one that we generally do, just like a closed circle is what we generally do when it comes to those features. All right, cool. So thank you for asking that. How do we know which side of the graph? Okay, I imagine this question is going to be asked a lot. So listen, I'm not saying I won't answer it. What I'm going to say is, wait, hang on. How do we know which side of the graph to shade for inequalities? What I'll do is, unless you ask me something specifically different that makes me find something else to add to it, what I'm going to say for this question here, wait, where's my finger going? I don't see myself in camera. This question, which question am I on? This question here. How do we know which side to graph? So I did answer that right here a little bit and right here a little bit. So unless you ask me, because there's another way we can shade things based on testing a point. So unless someone asks me about testing points, let's assume that we're trying to get things in slope-intercept form for now. So you can look at either of these questions and their respective timestamps, and I'm going to give you the proper timestamp for this one as well. Don't worry, you're probably not going to be the only last person to be asking me this, but I'll just let you know. Okay, here we go. How can you check to see if you got the correct answer in a linear system. Okay, so this is a perfect example of maybe I can do, because someone can ask this regarding shading as well, and this is perfect because I say you can either shade based on testing a point, or you can double check your shading based on testing a point. So, okay, how can you check to see if you got the correct answer? Well, you're not stating a system of linear inequalities specifically versus equations, but in either case, here's what we do. Well, I'll say it out loud first. Let's say it's a system of linear equations. A system of linear equations. What you do when we're kind of talking about graphing. Well, actually, I don't know if you're talking about graphing right now. But let's say that we're graphing in a system of equations. The point of intersection of those two graphs is the solution to the system. Let's assume it's just a single answer. Boom. So what you can do is you can test that point, that xy value, and substitute that x and that y into your first equation, and substitute that x and y into your second equation, and make sure that the left side equals the right side on both of them. Make sure that you get a true statement. So the double checking that I like to say is that you do a substitution of the x and y into both of your equations. Now, if we're talking about inequalities, what we end up getting is what's called an overlapping shaded region. So let me go ahead and show you what that kind of looks like here. An overlapping shaded region means if I'm doing my system of inequalities graphing and I have some sort of line here where I do the shading above, and I do maybe some other sort of line here, maybe a dotted line, and maybe I'm shading below that one here. The overlapping shaded region is the one I'm going to kind of do in purple right here, is this guy right here. This is the overlapping shaded region where you get shadings from both of them, and any point inside the overlapping shaded region becomes a solution to the system. Now, how do you check to see if you got the correct answer? Just like how the solution to a system of equations is just that single point of intersection, and you can plug in that one point to see if the left side equals the right side in both equations. What I would do here is I would test a point that's a solution to this system, which is any point in this overlapping shaded region. I can test this point right here. And as long as the first and second inequalities give you true statements, for me personally, I think you can trust that if this point works, then any other point works. And the reason I state the whole trust thing is because, number one, I'm trusting that you did the math right to make the left side greater than the right, or whatever it is when you're testing it, to make them true statements when you plugged it in. And number two, I'm trusting that you probably graphed your boundary lines correctly. That's not always necessarily true, but shading above one and below the other to get that shaded region doesn't matter if you accidentally, oopsie, the line was supposed to be a little more over here. You're still in the overlapping shaded region, if you know what I mean. So I would just test one point to see if it works. And honestly, what I would do really in another sense here is, let's say I didn't know which way to shade yet. I'm just going to remove it all. Let's say I didn't know which way to shade yet when I did those drawings. And let's say I had this, I don't know what my lines look like anymore. Let's say I just drew this boundary line here and this boundary line here, and I still didn't know which way to actually draw this. Shade this, excuse me. What I would do is probably try and test the point 0, 0. As long as 0, 0 is not on either boundary line here, it's a really quick point to test, because anytime you plug in 0 for x and 0 for y, no matter what else is with that term, it just turns into a 0. So there's very little to calculate. Just if there are constants and stuff, you like this isn't for either graph here, but earlier I said y is greater than or equal to negative 2x plus 4. If I substitute 0, 0 into here, I get 0 is greater than or equal to 4. The statement, I know this because y turns into 0. X turns into 0, negative 2 times 0 is 0, plus 4 is 4. You can see how fast I just write that statement out. Now, this ends up being a false statement here. And not that this graph is drawn, but if 0 is greater than or equal to, if this says this, and it's a false statement, that means you do not shade on the side that includes 0, 0. You shade on the other side. So if this was the equation for blue, which I know it's not. I know this isn't the one for blue. But if this was the one for blue, and I tested 0, 0, if 0, 0 doesn't work, then nothing on this side of the blue line works. Only points on this side of the blue line would work. So that's another way to know to shade. And I'm not sure if that's answering your question, how do you check to see if you got the answer correct? But this is how you can get the answer correct as well. Test some point. I would recommend 0, 0 really quickly for both lines to just shade in the right spot automatically. But you heard how I said this before. Test a point after you've shaded to see if it works for both. Whether it's, you didn't say system of inequalities or equations, so I covered both of them for you. Okay, so hopefully that covers that for you. Thank you for asking that question. And the next question, let me kind of go down here. The next question asks, how do you describe the solutions of linear inequalities? How do you describe them? That's a good question. I don't know. Did the book ever ask this? How do you describe them? You can say it's all the points that's above blah 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 line and all the points that's below blah 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 line. Yeah, here, look. If I had this one here, let's go back to the last example I just did. If I had this here, these two lines, this was about inequalities, right? Yeah. If I had these two lines here, and I said that this was the overlapping shaded region right here, what I could say is this, and I don't know if this answers this well for you or not, but the solution to this system are all of the points that are above now I'm just going to say the blue line, but you might have an actual inequality to write, like y is greater than or equal to 1/2 x minus 3. Everything that's above the blue line, including on the line itself, I should say the word bounded. Everything bounded by the blue line, including the line itself, and the above the blue line, and underneath the green line, not including that line itself. Because as you may well know, points on the solid line that are bounding the shaded region do count as solutions to the system. All these do. These ones on green do not, because the dotted line states that points on the line shouldn't count anyway. So anything above the blue or on the blue and below the green will count. When I said and, I mean both of them, because this is above the blue but not below the green. This does not count. It needs to be above the blue and below the green. On the blue also counts. I don't know if that really works there, but describing it, I don't know. If I asked you which region A, B, C, or D, we'd call it region B. That works there. Yeah, I don't know how it works when it comes to saying describe there, but I hope that my sentence kind of helped with the above this one on the line and below this one not on that line. All right, I was wondering about shading in the graph. Sometimes I find that and the dotted line idea difficult to understand. Okay, let me bring this about in another light, because so far you guys have been hearing how you know which way to shade. Some people still might not know what the shading represents. So if you're asking how to know which way to shade and whether you do dotted or solid line, look to, I'm going to give you timestamps for some of the previous times that I answered that. Otherwise, for your question, what I'm going to go ahead and do is answer what the shading is for. I already answered what the dotted and solid line is for, so check that timestamp. But why are we shading? Why are we shading, guys? I could talk about this for a very long time, so I'm going to I can't guarantee one way or the other whether or not I'm going to. Let me set this up first. I'll use an actual example to support it. I'm trying to create a graph inside here, and then I'll get you ready. All right. So, how do I want to present this first? There are two things I want to talk about first before I talk about the shading, and I'm sorry about this. The first thing is graphing with just an equation, like y equals mx plus b. And the other thing is graphing an inequality for a single variable. Whoa! Like graphing like a x is greater than, I don't know, c, whatever we're talking about. Okay. When we draw a line, what we tend to do, well, what we started by doing was plotting points in a table. We'd plug in something for x, we'd get something out for y. Let's say the equation said y equals 2x plus 1. What we would do is we would plug in 0 for x. 2 times 0 plus 1 is 1. When x is 0, y is 1. Then we'd plug in 1 for x. 2 times 1 plus 1 is 2 plus 1, which is 3. And we'd continue this in a table. Then you learned how to shorthand do this, which is kind of what I'm doing right now, is starting from the y-intercept of 1, you know that every point that comes after that we can easily plot is with the rise of 2 and run of 1. Why that is a whole different story. We're not going to talk about that. And of course, we can go down this way as well. Now, keep in mind, what I'm plotting right here is every y value when I move an x value by 1 over and over. But these are not the only points that are solutions to this equation here. You could also, first of all, this goes on forever. So you can keep going up 2 over 1 if you could actually have the room and if you had the time and all that stuff. But also every point in between works. You know, there is a point that if I substituted 1/2 for x, 2 times 1/2 is 1, plus 1 is 2. And so this gives you 2 if I plug in 1/2. So where's 1/2 comma 2? it's right here. This is a point that's also in conjunction. It's collinear with all of these other points right here. And you can plug in any x value in the world. It doesn't have to be an integer. We just so happen to plug in, and I promise I'm answering your question, we just so happen to plug in integer values just to make it easier for us to give ourselves enough precision so that when we draw a line, we've covered all the other points in between. So before we answer the question, why do we shade? The first question that we should probably answer is, why do we ever draw a line in the first place? We draw a line to cover the aspect of there's more than just these points to plot. There's a bunch of points, and instead of plotting all those points over and over and over, what better way to do that, more efficient than just draw a line? The line is another way of saying here are a bunch of points that make this thing true. I could plug in 0.36912, something like that, and I'll get a y value out, and it should match, left side will equal the right side. Solutions to an equation mean points on the line, or points on the line mean solutions to equation, vice versa. Now, if we talk about an inequality, before we get into this one here, if we talk about an inequality such as this one right here, x is greater than, let's just say 1, x is greater than 1, understand that there's more than one answer to this. 2 is greater than 1, 3 is greater than 1, 10 is greater than 1, 1,000 is greater than 1, 1.5 is greater than 1. 1 isn't greater than 1, 0 isn't greater than 1, -2 isn't greater than 1, but there are values that are greater than 1, and what we do in a one-dimensional case right there is, I'm not going to talk about the open circle, but you plot an open circle on 1, and we draw a line to the right, and the line is once again another way of stating that 2 is greater than 1, and 3 is greater than 1, and 1.5 is greater than 1, right? So we draw the line to kind of connect that whole idea, and we do that. So just keep that in mind. There's going to be more than one answer to these. Now, why do we shade? Well, what if we had y is greater than or equal to 2x plus 1? Now, there aren't just points on the line that are solutions to this inequality, because the left side doesn't have to equal the right side. The left side can also be greater than the right side. So the reason that we shade is because this point right here, -5, 1, when I substitute that thing in, y'all, is I get, hey, look at my background. It kind of matches my shirt right there. Purple and purple. I like that. -5 for x and 1 for y will still make a true statement. -10 plus 1 is -9. 1 is greater than or equal to -9. That's a true statement. That's a true statement. This point right here is greater than this point right here. And you might be wondering why I'm talking about this point right here, because this is the value of y that I just got when I substituted -5 for x. This y that I chose on this x right here of -5, this y that I chose is greater than the y that you get by plugging that x value. And that's what we're testing. So why do we shade? Because this isn't the only point that works. Any point above this line will work. This point will work, this point will work, this point will work, this point will work. And just like when we draw a line for linear for points on a line, just because, I can't talk, I'm sorry. Just like we draw a line to connect all our points because it's a lot faster, what's faster than drawing a bunch of points over and over? Because listen, guys, I have holes everywhere here. This is going to take forever for me to fill this thing in unless we just represent it with a shading. All of these points, you can test every single one that I plotted right there. Every single point here will make a true statement in the inequality. So what we do instead is we shade it. We shade it. We draw a shading that, I know I'm skipping points right there because I'm doing it really fast, but the shading is a representation of all these points work, just like points on the line work, just the ones in between. Every single point here works. It's a faster, streamlined way of saying it. These points will not work. That's why we don't shade on that side. So, again, I could go a lot longer with that. I'm going to stop right there and talking about it, but I hope that shading makes sense there. It's what makes a true statement out of plugging in that x and that y that we choose. Whereas these sides, because they're not shaded, is because it would make a false statement. It might say something like 1 is greater than or equal to 10, and that's not true. But if the left side is greater than or equal to the right side, then it is true. So there it is. Okay, I hope that covers that. And honestly, I don't know what other things people can ask just yet, but I might have covered most of the things regarding shading and dotted line stuff. So if more people have questions on them, I might point you to older timestamps and try and find the one that answers it best. Because, like I said, I imagine most people are going to be asking these questions, and because I have like 20 of them, that actually saves time for me on the Power Hour. Unless someone asks a specific kind of question that's a little bit different, that's mostly, I think I've mostly covered it. All right. When being asked to graph the inequality, will 0 always work to find which side to shade? So this is more of the testing points kind of question that we talked about before. When you say 0, I assume you mean 0, 0, because what we're doing, when you said shade, I assume you're talking about two variables, and we need an x and a y. So the answer is, well, the answer is no. It's not always going to work, and I'll show you when and why. But should you always consider it first? Yes. I mentioned why in a previous answer, that you should always consider it first because it's the easiest thing to calculate. You know what 0 times anything is? 0. And you know what x and y tend to be attached to? Some other number that's multiplying by it. So that whole term turns into 0. When they're by themselves, they turn into 0, the x or the y. So you don't really have to do any math except just compare the left to right side. Now, when you're asking, will it always work? It will not work if 0, 0 is on your boundary line. So, sorry, I'm working on this thing right now as I'm erasing parts from a previous question. This is the line. This is the line for the equation y equals 2x plus 1. Or here, let's say y is greater than or equal to. And you're deciding, hey, which side do I shade on this thing? Well, you could test 0, 0 and find out. Now, here's the thing. 0, 0, even though it's very close to the boundary line, actually happens to not be on the boundary line. So you're fine. As long as it's not on the boundary line, you're good. Because here, when I plug this thing in, I'll get 0 is greater than or equal to 1. This is not true. And because it's not true, we would be shading above because 0, 0 is below. 0, 0 is below. 0, 0 is false. Makes a false statement. So points above would make it true. Now, you can test 0, 0 as long as your boundary line, as long as it's not on your boundary line. But what if this was the inequality y is greater than or equal to 2x? Not 2x plus 1, but just 2x. Now what we're looking at, guys, is a line that, well, hang on a second. Now what we're looking at here is a line that crosses through 0, 0. See, I can't test 0, 0 because it's not going to tell me. I mean, it might give me a true or false statement, but 0, 0 is not on one side of the line or the other. The whole point of testing some point is if it's on one side of the boundary line, and if that one gives a true statement, then I shade everything on that side. And if it gives me a false statement, then I shade everything on the other side. Because that single point represents the same thing that everything else represents there. And 0, 0 is a nice, easy one to try because, like I said, it's really easy to do math-wise. But if it's on the line, whether it gives you a true or false statement, which it should give me a true one here, 0 is greater than or equal to 0, because it's greater than or equal to, it kind of looks like a face. Whether it gives me a true or false statement is irrelevant, because it's not on a side of the line, it's on the line. What, if I got a true statement, what does that mean? I shade above? No, 0, 0 is not above the line. I only shade above the line if the points are above with it. If it's false, what, do I shade below? No. So, can you always test 0, 0? As long as 0, 0 is not on your boundary line, yes. If 0, 0 is on your boundary line, no. I plan on leaving it off the boundary lines. I plan on giving you y-intercepts that are not 0. By the way, this would be 2x plus 0. So I plan on not giving you a 0 y-intercept for the most part, just so you can practice testing 0, 0, and you can practice graphing y-intercepts and such. So you likely won't see this much from me. Here I would try 1, 0 or 0, 1. I just try something that's really close as well. And if 0, 1's above it, and if it makes a true statement, then you shade above. So those are ways that you can test the points right there. But like I said, 0, 0 should only be something to test as long as it's not on the boundary line. And for the most part, it's not. So I think that works out. It's a good question, though. Thank you. Okay, Tom Brady. Tom Brady, also known as the greatest of all time, or Patrick Mahomes. I don't know what the question is. So, because I don't know if you're asking me who do I like more, who should win the Super Bowl, whatever. First of all, no credit for asking this question because it's not content related. Okay, for those who don't know, I hold a lot of bias with Tom Brady because I have personal connections with him. Nothing as if I could get you to. I haven't spoken to him in 20 years, guys. He wouldn't know who I was right now. I'm sure. I'm sure he knows who my dad was. After my dad passed about 7 years ago now, or six whatever years ago. His parents contacted us and such, so it was, the condolences. So I really know his sister though, Maureen Brady. I really know his sister. So anyway, I have bias over Tom Brady, and people always ask, who's my favorite football team. I do go for the Niners, and then I've always had something with an affinity with San Diego, the city, so I always went for the Chargers. Now that they're in LA, I couldn't care less, sort of. And when Brady came on the scene, because our family is rooted and connected with the Bradys, I always said whatever team he's on, I would cheer for. For the longest time, I always thought it was just always going to be the Patriots, so it was... as long as he's a Patriot, I assume I'm going to be a Patriots fan for life, because as long as he's there. And when he retires, maybe, I don't know. But I like Bill Belichick and stuff as well. And once you start to watch a team more, you start to like them as well. So I'm kind of a Patriots fan. But now he's on the Bucs. So you know what? I'm a Bucs fan. And you know what? They're in the Super Bowl. And why shouldn't they be? They have Tom Brady, the GOAT, the greatest of all time. So if you're asking who I like more, I like Tom Brady more. Now, I have bias also when it comes to who's going to win the Super Bowl. It's easy for me to choose someone like the Chiefs because I think that they are the favored team. They're the favorite for this scenario. Not by super much. The Buccaneers have really caught up in a lot of ways, both defensively and offensively. It's their special teams, actually, that brings them down a little more sometimes. But, the Chiefs put a walloping on them earlier in the year. Well, early in the game, earlier in the year, and then they only ended up winning by 3. But the Chiefs are a favored team right now. So it's easy for me to say that the Chiefs could win, but it's hard for me to stomach that thought of thinking that they would when I don't want them to. So for me, of course, I'm just going to say, well, I think the Bucs are going to win, and I think Brady's going to put it through. Regardless, I think both Brady and Mahomes are going to have great MVP caliber games, whereas no matter which team wins, that QB could easily just, normally they select them as the MVP, but I don't think they're going to struggle that much on their own terms. As in, they could pass to a player, it could pop out of their hands and someone picks it off. That, I don't call it, even though it's the QB's interception, I wouldn't call it their fault necessarily. So that could happen. But I think they are well-versed and prepped. They've both been on the scene before. Brady's been on it several times now. This is going to be his 10th time here, and Mahomes has gone here, I think, once. Just against the Niners last year. Because the Patriots beat him in the AFC Championship the year before, I think. Okay. Now, and I shouldn't spend too much time on this one question here because this isn't math related. This is the one that I'm actually most interested in answering. Mahomes is such a different kind of animal. Not that he's like Steph Curry, because I don't know, but he reminds me of Steph Curry in that you almost feel like he just rolls out of bed and he just has this raw innate talent to just play with people. Like, it's almost like the football field's a playground to him, and he can just do whatever he wants. He could underhand toss it, he could sidearm toss it, he could throw it with his left hand, he could throw it off his right foot, he could flip it backhand. He can just run out of the pocket and just dance around with players like that, and he can throw it very far and very hard and very accurately, and he just has such an arsenal that it feels so easy when we watch it happen. When other quarterbacks do it, it feels like they've earned it. It feels hard. It feels like what they're doing is really hard. I'm not saying that they're bad at it. I'm saying that it feels really hard that, like, gosh, they're the best of the best at this. There's no wonder we can't do this. When Mahomes does it, it feels like we can all do it. Granted, we can't, but that's the point. He makes it seem so effortless because he has such an arsenal to work with there and just toy with people. He does this thing really well. Brady does this too, but he does this thing really well where he can look one direction and know that he's going to go this other direction, but he does this to make the safety start to lean that way, and once he makes the safety lean, he throws in that other direction. He can pinpoint it. So Mahomes is someone he's not a force to be reckoned with, and he's worth every single penny. I don't know, it's $400 million or however much he's making. He's worth every single penny. No, $40 million maybe $400 million. He's worth every single penny, and he can be the next greatest of all time if he sticks with it, as long as he can physically stay up. I think he will. When he starts to physically deteriorate, I don't know if he has the same things that Brady has when it comes to reading a pre-snap, when it comes to reading a blitz, or when it comes to doing an audible on the fly and knowing what he wants to do in those and how he works in I don't know, just certain situations, things that Brady's done his whole life and he studies up on, and he's Brady, in the other way, is very surgical. Despite his 43-year-old age and such, and I'm not saying he has a bad arm or anything like that, but despite he doesn't have the same physical arsenal that Mahomes has, he makes up for it mentally. He makes up for it emotionally. He makes up for it by just rallying around the troops and making sure that he knows what everyone else does in their situation. He is very good in a lot of different ways. And there were so many certain ways that back in the day, I can't always say that here now, but back in the day it was like, you know what Brady doesn't do, that I'm just kind of saying out loud, is that like he knows, gosh, how do I say this? You know, if someone's running cross route and they're running in the middle of the field, he knows to throw it in such a way as to not make that when they catch it that they get drilled. Maybe he'll throw it against their back shoulder so they turn around and soften up their run. You know, he's going to make sure to not screw someone up there. He knows when to throw a ball away as opposed to take a sack and lose yardage or run down time or fear of just getting picked. He knows when to do that every single time correctly, it so seems. And it always seems to be that when he chucks a ball downfield, he doesn't miss. This is something of more of old. And he knows he has to look. He's not fast. So he knows how to work and step up in a pocket. And he knows how to feel pressure on his backside. These are things that a lot of other quarterbacks don't know how to do, and that's something that Brady's just really good at there. So anyway, I'm spending more time answering this question than anything else. So just for the person who's asking about it, I don't know what you want me to necessarily say when it comes to it. I want the Bucs to win. I feel like the Bucs have a legit shot at winning, but the Chiefs have Mahomes. The Chiefs have Tyreek Hill, who had 200 yards in the first quarter when they played him last time. I mean, Hill plays with them with like the juke stick, right? It's crazy. I don't know how they're going to do that. And if they double him, now they have Kelsey. And Mahomes and Kelsey are like this. So it's really tough to figure that thing out. But the Bucs defense is so improved. And the Chiefs offensive line has been weakening a little bit. I think they have 2 injured offensive linemen. That hopefully they can put the right pressure on Mahomes. Because Mahomes isn't as good under pressure. And if he can't get out of the pocket, there's a little bit of a problem. So we'll find out who he can dump it off to. But I think if the Patriots can great. I feel like if the Bucs can get out on top early, if they can start with the ball, they might try and receive. I'm betting this. We'll see if this happens. If the Bucs are the first to get the ball and they touchback, they down it at the 25. I think the first play from scrimmage, I don't know, these are improbable odds that this will happen. The first play from scrimmage that the Bucs should do really is just a downfield pass. They should just bomb it. The first several plays they've been doing from scrimmage have been a handoff. It's been giving 3 yards or so. They've been getting a few 3 and outs, except for against the Packers. They've been getting, because they've been converting on third down, they've been getting a few 3 and outs that I think otherwise it would have been better for them to, I don't know. I get what they're doing. They need to establish the running game, and that's part of the point that I'm going to make here. Be unpredictable. Make a big downfield pass and overthrow your target, if anything. And if it's incomplete, just kind of work from there. Just try and get a first down after that and then start doing the running. But if you get a first down there, you can really establish the running because now you're backing up your safeties and your inside guys probably won't be able to blitz from the very beginning just in case something like that happens again. They need to be able to now cover the outside. So if you're complete, you can also do some runs because you're probably near field goal range if you got a 40-yard pass in. You're probably in field goal range. So if you get to fourth down, the worst that happens is you're still up 3 points. Field goals aren't guaranteed, but the worst that happens is you're still up 3 points. So once you get downfield, you can establish that running game and push forward into possibly getting that touchdown. And if the Bucs start off on top after a share of drives for the Bucs first drive and the Chiefs first drive, now they can really establish the running game. Now it keeps the other team on their heels, and any outside blitzes can be countered with an inside run, and they can chew clock. And the less time that Mahomes is on the field, the better chance the Bucs have at winning the game, because the Chiefs are going to get their touchdowns. The Chiefs are going to score. I don't know why the Bills kicked a field goal that one time to go up 10-0 or whatever the score was at the time, thinking that, this is let's make sure of these points. No, you guys got to get a lot of points because the Chiefs are going to come back up. The Chiefs are going to get their touchdowns. They absolutely are. So you got to get as much as you can at the time, and you got to chew away some clock if you're the Bucs. All right. I'm off that question. Thank you for asking me that question, though. I don't know if I even answered it for you. And 0 points for asking me it, but I'm glad to have answered it. All right. What's your policy on misspellings? I'm glad that you spelled misspellings correctly, by the way. Policy. I don't know what you mean by policy. You mean philosophy? I don't like misspelling, philosophically speaking. I always hate when rappers are Lil this or The Weeknd. He's not a rapper, but The Weeknd, I found out once that he doesn't. I don't know if he has a 3 or if he's missing an E or whatever. I don't like that they're misspelling those things. Guys, learn to spell correctly. Philosophically speaking, I rage against that kind of stuff. Policy, I don't really know what you mean. I might laugh out loud whenever I see something that's hilariously misspelled, and it's a cute thing. You guys are young. If you're talking about, listen, we've been doing a few more writing things in class. By the way, you don't get credit for this question either. It's not content related, but we've been doing more things in class when it comes to writing. Whether it's actually writing the answer to a question, or whether it's the Boy Meets World thing that we're doing on the Eskimo journal entry, and whether it's the Q&A Power Hour follow-up things. I ask you guys to treat me as if you treat an English teacher, okay? Don't assume that I don't have, not a policy, but don't assume that I don't have, not expectation, that I don't have some sort of level of wanted need for you to, spell something correctly. That I don't have a standard. There we go. That I don't have a standard for just spelling things correctly. I love this purple. It's kind of matching. Hang on. If it gets more purple, just let me know. Some kind of standard for, spelling things correctly. If you misspell something and you're aware of it, I would love for you to go out of your way to go back and fix it. I think if that answers the question best, I think there's that. But more importantly is being grammatically correct. And I'm not embarrassed because we don't know who you are, and I don't know who you are actually right now. The first person who asked the first question here says, how do you wear you are supposed to shade? How do you wear? Right, it's how do you know where you're supposed to shade? And that's the kind of thing where, I want you, before you submit your questions, guys, reread your question, because I might misinterpret what you're asking. I think you meant to say, how do you know where? And I'm going to take it at face value. I copy and paste these things in. I take it exactly how you spelled it. So make sure that you guys are rereading those things as well. So there's no policy, but assume that I have the standard such as any other educated adult would have as far as standard goes, that, make it look like that you're trying. I don't know. You guys have been not you guys, but like your generation and stuff, you guys have autocorrect and stuff on your phones, and sometimes you guys get away with it so much that you never actually learn the proper way to do something. Just like being given a calculator, you might not be given the proper way to calculate something at the same time. So, you should still be learning to spell, despite the facts that you might have an autocorrect or some, that Google can tell you, did you mean this? Anyway, I don't know what you mean by policy on misspellings. I don't really have one. Unless I ask you to spell something correctly, then I'll take off credit. But don't go out of your way to misspell something. And if you notice that something's misspelled, try and correct it for me. It gives a better impression for me. That's all. Okay, when shading, is it possible to get such a small solution area, the darker shaded spot, that there aren't any solution points? Well, no. When you're saying the darker area, I assume that you're referring to the solution to, the system of inequality, the overlap. I assume you're referring to the overlapping shaded region. So if I'm using this line here, and let's just use them all blue, and this line here, and this line here, and it's greater than this, and less than this, and less than this, then here's the overlapping shaded region, and it's a triangle. And we haven't done 3 together, but this is the only way that I can really talk about what you're probably asking. Is it possible that this overlapping shaded region is so small that there's no solution points? Remember, as long as there is overlapping shaded region, then there are solutions. So no matter how small this region is, as long as there is region, there are solutions. Sort of. We haven't been doing word problems, but if your word problems can only have integer answers, and this thing doesn't cover any integers, it doesn't actually cross through any integer points, then I see where maybe there are no solutions, or where it only goes in the negative territory, and your word problem doesn't make sense to have negative answers. It's like -3 people, or 2.5 people. If none of those answers make sense, and those are the only ones in the shaded region, okay, no solution. But as long as, one more time, as long as there is any overlapping shaded region, there is solution. Remember, there's an infinite number of values in this shaded region, even right here. No matter how small it is, there's an infinite number of values there. There's -1 and -1.1 and -1.01 and -1.001 and -1, all those are there. There's an infinite amount, so if you have any region at all, there's an infinite solution set. So no, it's not possible unless you're referring to some sort of restricted domain. or only integers or something, and it doesn't hit any integers or it doesn't fall in your restricted domain. And that's normally from word problem context, and we're not dealing with word problems. Okay, how many math tests and quizzes will we have this quarter? So this is not a content-related question. It's a curriculum-related question, and I answered this question. Actually, I don't know if I did. I'm not going to say I answered this question. I might have done it for IM2. Okay, I'll answer this question for you. I think we're doing this. We're finishing this unit here. And then we have, I think, 3 more units after that. So tests, we still have 8 more. 4 group tests, 4 individual tests. 2 per unit. 1 group test, 1 individual test per unit. Quizzes, we will have 1 to 2 per unit. So you can assume anywhere between 4 and 8 quizzes for the year. But this is not content related, so no credit for that. All right, for someone like me who is a little bit slower when it comes to math, what do you suggest I do on a group test if my group is a bit too fast for me? Well, I'm hoping that everyone is together, so I'm hoping that they can help you with pace. It's about educating each other. I also hope that my group tests aren't so large that even catering... See, we have to cater toward the lowest common denominator, to the slowest individual in any group, and I know that some people are slower than others. I hope you don't mean just a slow writer. I hope you mean like slowly processing. You need to get it, you need to grasp it, you need to figure it out. I think that I'm giving you enough time, few enough questions to have enough time to discuss the questions on a deeper basis to make sure that we're all caught up, that everyone's kind of understanding it. The point of the group test is to help the lower people when it comes to learning and understanding, or when it comes to processing, be up a little more in terms of learning it, or in terms of your grade, or both. It is to help you on a moment where it does matter before the test, and your other group members are going to have to wait. And I'm not saying that they're going to have to be patient. Everyone's at a different speed, and I hope that they can be patient enough, but everyone's going to have to be on that same even keel together, because you guys are sharing the grade, and I might be grading your questions on some things, and I might be looking at your scratch work. So for someone like you, what do I suggest? There are some ways to be more efficient on problems. If you know how to do the problem, but your step-by-step stuff's a little slower, maybe someone else can work with you. They can share their screen or what they wrote and tell them what they're writing to just work it out more. You know me, when it comes to me, if I'm subtracting 2x from both sides, I'm not always writing minus 2x, minus 2x. Even if that saves a couple seconds there, anything that might help. Otherwise, they should be sticking with you. I understand the question. It's not content related, but I understand the question, and I hope that what I said kind of helps with that notion. Thank you for asking it, because I think a lot of people will be in this boat in terms of, like, we're at different speeds. How do we work together? Personally, I just think you're going to have enough time. I think you're going to have enough time to stay slow, and I hope that's okay. All right, what is the easiest way to find out the side to shade when doing the inequalities? Even though I've already answered how to do it, you're asking easiest. I would recommend that you get it in slope-intercept form. The reason is because then you can compare the y to the y on the line, the y that you choose as a point to the y on the line. You don't literally have to compare it. You don't have to test a point. It's just that that's what the slope-intercept form thing does. You compare y. Is y greater than it? Is y less than it? Are we above or below? So when y is greater than, we get to shade above. When y is less than, we get to shade below. I believe that's the easiest way. Get it in slope-intercept form. Get y by itself. Even when you graph quadratics, it's not called slope-intercept form anymore. But when you get it in that y by itself form, you get to shade above or below based on whether it's greater than or whether it's less than. That'll always stay true as far as that, as long as you're comparing y to something. So that's what I recommend. The only thing you got to be careful of is if you divide by a negative at any time, you got to make sure you flip that inequality. That's the reason I sometimes ask you to double check your points and test them. Okay, for the group tests coming up, are we going to split up the work with our group, or do we do the work together as a group? Again, not content related, so no credit for the question, but it's probably a good answer to, probably a good question to get an answer for. As far as how you choose to how you want to pace yourselves, that's your call. If you want to say, guys, I'm going to do number 1, and you do number 2, and you do number 3, and then we come back together and talk about it, that's fine. You can do whatever you want there. I would recommend against that as long as we're distance learning, because it's harder to kind of talk with each other and share things. I'd rather you guys probably work together, just to kind of keep the pace together as long as you're distance learning. If you're group testing in class, some people might look to do something like that as long as you trust each other with answers and you can report back and you think that'll be faster. Or two of you guys work on this one problem and two whatever. But in distance learning, I say you all work together. Now, if you're asking me in the way of like, because you guys are sharing the grade, if someone just does number one and another person just, let's say there were 4 questions, 4 people in the group. One person just does number 1, another person just does number 2, one does number 3, one does number 4, and I grade it that way. That's not necessarily how it would work. No. I'm going to randomly grade one person. Among that group, I'm going to randomly choose one person's number 1, and if they left it blank, all you guys get a 0 on that. So everyone will have to fill out the entire thing in the end, whether you split up the work and reconvene to tell each other what to write, or whether you work together as a group. You guys are all filling out the entire, just make sure you know that. You guys are all filling out the entire test because you don't know whose problem I'm going to choose at any one time. And it's going to be random. I'm not going to go out of the way to go, haha, this person didn't put anything. So I'm going to intentionally lower your score because you guys should have. No, if you might get luck of the draw and maybe someone didn't answer something and maybe someone else did and maybe I land on someone who did. And then therefore the person who didn't answer anything still gets credit. But I wouldn't count on that because it's luck of the draw that way. So you're saying, are we going to split up the work? You can choose. I would recommend against it. You can choose to split up the work as long as you come back together and do it. But make sure that you know that, no, you do all have to turn in every little bit as students just to ensure yourself that it gets graded properly. Okay, why is system of inequalities important when we are older? Why do we need it? This kind of question, I'm not saying it stirs me the wrong way. I like that you're asking it, but I feel like this question can be asked for any content thing. If you're somebody, pretty soon we're going to do exponential functions. I hope you don't just come back the next time and say, why are exponential functions important when we are older? Why do we need it? So, it's an easy cop-out is what I'm saying. For some people ask this out of sheer curiosity. Some people ask it as a cop-out. And then some people ask it even to deflect in a way of, and I'm not saying this is you. I don't know who you are. I don't know. I'm doing this part first, and then I'll answer a little bit. I'm not going to go deep into this. Some people ask this as a means of deflecting. Mr. Robinson, I don't know how to do this, so why does it make sense for me? What give me reason to need to go out of the way to learn this because I don't get it. So I'm going to deflect and say, I don't need this. Why do I need this? I don't get it. So why should I use it if I'm not going to use it? Why should I bother getting it when I can't? So I don't know which one you in. Are you sheerly out of sheer curiosity? Is it because you could ask it, like you could ask it for anything? Why is cursive important? Yeah, I don't know. Or is it a means of deflection? Now, why is it important when we are older? Why do we need it? Not everyone needs it. I can't think of a lot of times. I can think of several times where I've used it outside of teaching and outside of math. I've used it as a programmer. I've used it a lot as a programmer. You can use it when you do linear systems of linear inequalities word problems is where you'll see the most use of it. And I think I've given examples to you guys as students. Hang on, I'm going to pause my video for a second. I'm getting a phone call. One second. Okay, I'm back. Did I unpause? Okay, yes. Okay, I'm back. Sorry. Okay. What was the question? Oh, when do we use it in real life? Okay, so I use it in real life, not only as a math teacher and such, but I really wish we did linear systems of linear inequalities word problems. And listen, you're going to do them later. You're going to do them in probably more so IM3 than IM2. But no, you're going to do them in word problems. Okay, I'd say IM3, Integrated Math 3. When you do, look up something called linear programming. It's where you optimize and try and figure out how do you maximize or minimize cost on something based on constraints that you have. The amount of supplies you can have, how much you're going to charge for something, blah, blah, blah. There are ways that people could use them in real life. You wouldn't necessarily have to, but that's the whole thing with all this algebra and stuff like that, guys. There are a lot of... Algebra can help make things, or math can help make things really efficient, or they can help you build and understand the logic of something, and you have the ability to use it. Whether you choose to use it or not, it's up to you. I'm not going to dictate how you're going to run your life on those things. If you get into programming, you'd use inequalities a heck of a lot. It's systems of inequalities as well. I do this thing that I sent to all the teachers here at Rio where in distance learning, attendance tracking is kind of a bummer, where if we're in class, we can see a seating chart, we can see where there's an empty seat, and we can just mark that person absent. Here, you're sorted by first name on Zoom, or you're sorted by last name on Q when we do attendance, or you have a nickname on Zoom, or you have this on Q, and we gotta spend time taking roll when we're already losing time in distance learning, trying to see if you're there or not. There are a lot of things that kind of get in the way, and it made it kind of cumbersome for me to the point sometimes I forgot to take attendance, and it takes a long time to do. So what I did, I spent the time, and I sharpened the axe, got it ready to chop down the tree instead of going straight away to it. I developed I'm a programmer. I came from a computer science major. I developed a thing in Google Sheets, an algorithm, if you will, a way of when we can copy and paste your guys' emails out of a Zoom log, when it pastes in, it automatically tells the teachers what students were absent. And I'm not saying it's an easy or hard programming necessarily. Not anyone could do it, but I had to use systems of inequalities to make it happen. And I'm not going to explain how it is, but I'm not going to explain how it is that I used it. But I used systems of inequalities to mark certain constraints when it came to making the logic in the coding work. So when did I use it in real life? I use it to help every single teacher at Rio Americano High School make tracking attendance for all 5 or 6 of their classes that they teach be done in like 2 minutes as opposed to like 15 to 20 minutes. So it can be a lifesaver to do it that way. Same with the linear programming thing that I talked about. You can optimize things in a certain way. And let me, I'm not going to get deep in the linear programming thing, but let me just give you the picture of what this ends up looking like here in linear programming in that sense. What would happen is in real life context, you might be provided constraints on some inequalities here, and it would be more than 2 for the most part. Let's say there was an inequality here where we had shade above this and below this and within this, and we have the shaded region right here. And this shaded region represents any sort of point for X and Y. And I don't know what X and Y are. It could be a number of quarters, a number of dimes. Like, I don't know. But you're restricted to be within these constraints based on whatever the word problem told you. Now, what linear programming does is it kind of tells you that wherever the points of intersection are of these things are where you can maximize or minimize something regarding cost or weight or capacity or something like that based on what's called an objective function. And I'm not getting deep into that. All of these things are solutions, but only these points right here are the ones that maximize or minimize your objective function's ability to increase or decrease your values for something. And if you have real life constraints like the word problems show, again, we didn't do any, but if you have real life constraints such as those mixed within there, this is the fastest way to go about doing it rather than to logically figure it out. This gives you exact answers right then and there. It makes it very easy for you. So again, I don't know how you would use it in real life. It depends on who you are. But listen, all the logic that's involved, if you're trying to deflect, all the logic that's involved is very helpful to you. You still got to learn it for a test. So that's as much as I can say there. Okay. Will we be taking a final at the end of the year? I answered this one. Well, I don't know if I did this in IM2 or IM1. This is a curriculum-based question. We will be taking a test probably on the last day or the day before it, but it is just on the next unit. It's going to be on like unit 8 or whichever unit that we're in. It's not going to be more heavily weighted, and it's not going to be cumulative. So, no, we won't be taking a final, but we will be taking another unit test at the end of the year. Okay, when graphing systems of linear inequalities, when do you shade above the line and below the line, and when is it going to be a dotted or solid line? So I've covered this answer. I'll find the timestamps for you to see the answers to that question very specifically. So I am going to move on. Because I've answered everything within there. Will we ever need to solve algebraically what the answer is not when solving systems of inequalities? Technically, when you find out what is, then that does answer what's not. When we look at this is a different kind of graph, but I just did this for a different example. When we look at this thing right here, and this is the overlapping shaded region for these 3 boundary lines, okay, then anything within this, including on the lines themselves, are solutions. Anything that's outside of it is not. Anything that's outside of it is not. So, will we ever need to solve what the answer is not? When you do solve what is, you are solving what's not. So, will you ever? Yeah, you do it all the time. You guys don't focus too much on. Are you guys doing domain and range with me? Or is that just IM2? I think that might just be integrated math too. You guys probably don't know much about domain and range stuff. All I'm just going to mention here is that, listen, there are certain x values that you can be within here. So like, okay, when we say something like x is greater than 4, that's also saying that x is not less than or equal to 4. But we don't need to say the not less than or equal to. We can just say greater than, and that tells us that less than or equal to is not, if that makes sense. So sometimes we might say something like x is not equal to 4, which basically, when you said what is not here, that's also another way of saying what it is. It's anything else. It's any number in the world. Any number in the world works, but 4 doesn't. So this happens sometimes. This isn't for systems of inequalities. This is, I guess this is technically an inequality. It's about comparing x to something in terms of what it might not be. So I guess it's technically an inequality, but it's not a greater than that you're talking about. You'll be doing this a lot more when you deal with what are called rational functions, what x cannot equal, as opposed to what x does equal. But again, answering one does answer the other, because these are mutually exclusive things. Like, you can either be heads or tails. It can't be both. It can't be neither. Once you've stated one, the other is automatically applied. You know what I mean? So I hope that kind of addresses your question there. I think I covered it in kind of a way that does make sense with that. All right, here we go. For the group test next week, are we able to choose the people we want to work with on the test? So I assume that this was asked before I did the thing that I did at the very end of this week, where I gave you guys a survey to state who you wanted to try and work with on group tests here. Now, I gave you guys a choice of 3 people. If you weren't in class at the end of Thursday or Friday, then you missed out on this thing. I told you to stick around for a survey. If you were in class at the end, you were able to fill this part out for the survey. Are you able to choose? So what I did was I gave you guys a survey, and I said choose 3 people who you'd like to work with on a group test at some point this year. And I promise to do my best to make sure that you work with at least each one of them at least once. I can't guarantee you'll work with them more than once. I can't guarantee you'll work with them all together. I can guarantee that I'll be able to get you to work with each of them at least once. I'll try. Now, you might have chosen them. They might not have chosen you, and they'll be none the wiser if you were placed together because it was random, or because they was placed because you requested them, right? Because you might be with a crush. You might be requesting a crush and like, I'm never going to choose that person. You know what I should have also put is name someone who you absolutely do not want to work with. And listen, they would never know one way or the other unless you're like, well, I requested that person. Why didn't I work with them? Well, because they didn't want you. So I don't know. But I'll try my best to pair you up with each of them at least once, so you're not completely bogged down when it comes to a group of 3 Randys who you've never met, who you'd never talked to. At least a little bit. What I'm probably going to try and do is probably try and pair someone. If you wanted to work with person A and this person wanted to work with person B, I'll try and make sure that I get you with person A, this person with person B, and you guys together as a group of 4. That way, you guys know someone who you for sure can talk to in there, and then that opens the floor to just talking to the others as well. It kind of creates the dialogues. That's kind of my plan. That's why I kind of want the groups of 4 instead of groups of 3. So, are you able to choose? I gave you a little bit of option leeway if you were there in class at the end of class, just Thursday or Friday. All right, what is boot camp for Rio? You know, I feel really bad, and I don't know if this is the same person asking me before, but someone asked me if I was teaching boot camp in the curriculum question things before, and I said I didn't know what it was. I even tried to Google it, and I didn't know what it was. And the thing was, I do know what it is, I just didn't know it was called boot camp. So, what is boot camp? And if you're asking this, it's probably because you might have received an email for this. So here's what's happening. As a result of distance learning, there have been a lot of struggles for some people to kind of pass a class the way that they otherwise probably should have been able to. Maybe they had a lot of connection issues. Maybe they had a lot of tangibility issues, just being able to like literally connect with the teacher or connect with the material, because they have to do a lot more things electronically. And, you know, a lot of things screwed people up. They didn't get the one-on-one that they needed, or whatever it was. And we as teachers understand that, and we understand there's some people who probably just skirted underneath the F line, or underneath the D line, I guess, to get an F. But you were in class. You were giving the effort. You had tried and submitted homework and stuff, but maybe some things weren't working perfectly. Boot camp is kind of a summer school, but it's not during summer. And it's during the school year. And what's happening is there are some teachers, I don't remember all the teachers by heart who's doing what, but there's at least one teacher for IM1 and for IM2 for sure. I only know that because I teach IM1 and IM2, who are taking a pool of kids who were probably in the 50 to 60% range, 50 to 59% range of first semester, fall semester. So you didn't pass the class, but we're giving you a few hours, I don't know how many total, but a few hours during the course of this semester to try and relearn some of that material and get another chance to kind of pass that first semester. That you were on the bubble, you have the ability, you just got to kind of hear it again. You got to get a little more attention. We got to get you in there and doing it. So boot camp is the reason they might be calling it boot camp is if you know what boot camp is, it's kind of like a rigorous, hard and quick and fast like training thing for soldiers and stuff to kind of get ready for battle, to get ready to go on the next thing. I mean, they're going to drill you pretty fast here, right? They're going to work pretty fast and pretty hard there in making sure that you are honing in on your craft and getting a little better. Okay, we're near the end here. And getting a little bit better with that material. And if you were selected, it's because you were in a certain percent range there. Now, I'll let you know right now, I did select some students who had a D- in some capacity there because I think I think there's still stuff that you can learn. I think that it's important that you still go back because it's still important for the semester. It's very important for next year. You're still doing algebra next year, of course, and the year after that. And if you fell through the cracks in some capacity, remember, it's not all just about not getting an F. It's also about making sure that you're ready so the next time you also don't get an F and that it's easier for you. So boot camp is something where you can opt to be in or opt to be out. It's up to you. And you have the ability during the school year, without needing to go to summer school, being able to, on your transcript, actually change the grade that you got, which is possibly or likely an F from first semester, into a different grade, whatever it is. I hope that you guys learned something from it. I also hope that it's not an easy A, that suddenly all the work that we did together, you can just shrug off because of that. Now, if you got a low F, like a 10%, and you weren't showing up in class and you weren't doing any work for something like that, you likely weren't selected for boot camp, just so you guys are aware. This was not content-based, by the way. But I hope you asked another question around this. But if you were the person who asked the one in IM1 in the curriculum Q&A Power Hour, I'm sorry for not having answered your question the first time. I really am. I'm sorry. Okay, what do you mean by shade above or below? Also, why are some graphs shaded really dark while some areas of the same graphs are lightly shaded? Okay, so I answered the first part about above or below before, so I'll be sure to give you the timestamp on that one when this video's up for whenever I answered that. Your next question is something that I've not answered, though, as far as shading lightly or darkly or what have you. So, I have been mentioning to others, I'm getting a graph ready. I have been mentioning to other students something called an overlapping shaded region. The overlapping shaded region. And what that involves here, if I have a line here and I want to shade below it because I'm less than whatever, so I shade below here, and then I have some other inequality that's maybe this line and I shade above this line, we construct this thing that's otherwise known as an overlapping shaded region. Now, right now, as I'm doing different colors, I'm just doing it to distinguish the both, so you understand why I'm shading below blue and above green, but now within here you have this thing called overlapping shaded region. Now, if I make this thing black and white, what you'll probably notice, this isn't perfect here, but what you'll notice probably a little more so, that's not really well done. Let me do this shaded, sorry, let me redo this. Let me do the shaded region so it's like actually filled in. So I'll do, my bad. So I'll go, whoops, I'm going to make that blue. Well, you know what, I'm going to make it black and white anyway. So I'm going to shade there, and then over here I'll do that same kind of graph, and I'll shade above this one. Well, here, when I shade this, well, I'll do this one blue, and then I'll make it black and white later. Okay, so thick and blue there. All right, even though it's weird there, sorry for the color mix-up. Don't worry, I'll make it black and white. What you're going to notice is the overlapping shaded region is going to appear darker than the other parts, and you're asking about lighter versus darker, so let's take a look there. So you'll notice that this region here, oh, sorry, my graph, I'm not looking at my screen there, my graph's a little off. Sorry about that. All right, so you'll notice here that this part was darker, because what I did was I put shading upon shading. That's why I ask you guys to shade lightly. For one, you might want to erase it, and for another, so that way the dark one can kind of show up more. It can distinguish itself from others. Now, why, wait, what is your question? Why are some graphs shaded really dark while some are shaded light? Most all of them should have an overlapping shaded region somewhere, unless we shade above or below parallel lines. which it looks like no one's asking about that. But the overlapping shaded region represents the solutions to your system. It means it is greater than this line, it is less than this line, or equal to. And we need to satisfy both of those lines together, the greater than or the less than things, right? So the overlapping shaded region is the solution set. The shaded stuff, the lighter shaded stuff, are not solutions to your system. They're solutions to a single inequality. This area may be greater than this line here, but this area is not less than this line here. And to satisfy the system, you need to make sure that you're in the overlapping shaded region. So what you'll see on some answer keys, depending on what kind of worksheet or textbook or whatever you're looking at, what you'll see sometimes people erase the shaded. I hate when this does this. When they sometimes erase the lighter region stuff, because technically these aren't solutions to the system anyway. So they're like, okay, we found the overlapping shaded region. We'll leave that there. The reason I kind of like the light stuff is to just note what was there. See now it's got messed up. Sorry about that. I don't know why that happens. Anyway, so you know that this constituted things that worked for one inequality but not the other, and this worked for one inequality but not the other, and this is the one that works for both. So the overlapping shaded region, guys, is the solution to the system. It is the solution to the system. These are not. These just denote what worked for one of them or the other. This works for neither. So I do like that it denotes that kind of thing. And again, if this was word problem, it would make sense to talk something about this or something about this, even if there are not solutions there. So just so you're aware, the darker part is the solution set. Where they overlap is the important part. Okay. All right. When removing decimals from an equation, like 12.30x plus 15.40y equals 1120.14, to make it easier to divide, why do we not add the decimals back on at the end? You mean at the end? Hang on. Let me write this. Because, I mean, I know you're not asking. I know this is just a random example. I'm going to change your example a little bit, though, because I'm going to change the 1120.14 to a 0.15. So 12.30x plus 15.40y. Even though, listen, I know what you asked might be a thing to an actual question. Actually, I'll do 1120.10. Let's money. And I don't know if it gives you good XY answers or whatever. Now you're stating, all right, we do a decimal shift, or we remove the decimals, whatever. We put these here. Were you asking why I don't just write the decimal right there, where I write 1230 point x plus 1540 point y? 1120 point, or whoops, 10 point? Technically it's 0.0, but is that what you're asking? Let's see. When removing decimals from an equation to make it easier to divide, why do we not add them back on at the end? So at the end, oh, you probably mean after you divide, why not bring them back? The whole point of moving the decimals over, listen, once you move, and I don't know if this kind of looks like a money problem now, almost like dollars, right? $12.30 plus $15. Once, like when I move the decimals at the end here, thankfully, with money, there's still some context in this. $12.30 also means 1,230 cents. So there's still context with this. But if I say divided all these by 10, divided by 10, because there's a 0 at the end, or I made a 0 at the end, it becomes 123x plus 154y equals 11201. This has less context to the problem. I guess this is how many dimes there are, but this is less context to the original problem. So once I start doing the division, the context of the problem, if we're talking about a word problem, does maybe fly out the window. So there's a little bit of a problem with that. But the reason we remove the decimal is to make our math easier for ourselves. None of us really like decimals necessarily. So getting the decimals out of the way gives us a better perception on how to make our number smaller. Just like when I divided by 10 to do this, it helped me. Now, if you're asking why not put the decimals back, because the numbers might have changed a lot, and the context probably changes, and that defeats the reason why we remove the decimals in the first place. We moved it to make the math easier. Bringing it back, whether you put it here or whether you put it whatever, it makes the math harder again. So, whoops, I put it in the wrong spot. Anyway, the point is, and I would have, personally, you should have asked me the question without giving me the example, because I probably would have given a fairer example to kind of show you this a little better. Okay, here, let me write out a different example here. It'll be pretty fast. Let's say I had 2.5x plus 5y equals 7.5. So right here, when I move the decimal 1 over and 1 over, no, I'm not going to put 5y point. That'll be a 50. This becomes 25x plus 50y equals 75. Now, in this case here, if I divide everything by 25, that'll be x plus 2y equals 3. Or 1x plus 2y equals 3. So in terms of answering your question, number one, if this was a word problem about, something like dollar amounts and whatever, this is a bad example. But if this was and it's a bad example because x equals 1, y equals 1 is probably one of the answers. But here, gosh, what was I just saying? There was original context to the way this thing was built if it was a word problem. Now I'm at 1x, 2y, and 3. Suddenly there's no context to the 1, 2, and 3. It's irrelevant to what we're talking about anyway. Bringing back a decimal is not going to help provide more context than there was. And the second reason is we did this to help us divide because it made the numbers easier. Bringing decimals back doesn't make the numbers easier. It makes them harder again. So we removed the decimals for that reason. Make it easier. Don't make it harder again. And again, the context is already defeated. No reason to bring decimals back anyway. So again, I hope that answered the question. Sorry for using your example. I really just wanted to use my own, but I hope that did answer it. All right, and the last one is how do I graph an inequality? I'll state that I did answer this already a bunch of times, but you know what I did not do yet? You know what I did not do, and no one asked it, but I'll go ahead and do this, is not how do I graph it, but how do I get it in a graphable form? Let's say that you're in standard form. Let's say we have something that says 2x minus 3y is less than or equal to 9. Okay. I would recommend that you get this in slope-intercept form for the reasons that shading in slope-intercept form steps easier. Now, I've mentioned that in previous problems, so I'll make sure to give you the timestamps for that. But I have not gotten this in slope-intercept form yet. So if I subtract 2x from both sides here, I'm getting in slope-intercept form for the reason it's going to make it easier for shading above versus below and such. And because you know how to graph out of this form pretty well. Now, here's the thing. I'm going to divide by -3 everywhere here. And I'm going to get y, hang on, let me see my screen. Okay, I'm going to get y, and I'm going to get positive 2/3 x, and a -3 because the sign changes. But here's the thing, now this inequality flips, not because I divided, but because I divided by a negative number. And I'm not going to get in why that happens there, because no one asked about it. But yeah, you flip an inequality when you divide by a negative number. So what I recommend is, if you're in some non-slope-intercept form, get it in slope-intercept form, and then it'll make the graphing easier for the reasons that I've already answered in this video earlier. You know how to graph this, and it does help you with the shading. But when you get in slope-intercept form, make sure anytime you divide or multiply both sides by a negative that you do flip that inequality. All right, so that ought to do it for this one, guys. This is Mr. Robinson here. Thank you for watching Mr. Robinson's Q&A Power Hour. A little longer than an hour, probably because I was talking about Brady a lot. And thank you for that, and you can follow this up, watch any portions here, and I hope it helped. All right, take care.